Hello everybody, this is going to be a demo on FlowStorm, on debugging Clojure code using FlowStorm. FlowStorm is a Clojure and Clojure script debugger, but today we are going to use it to debug some Clojure code. Okay, before starting, I have an Emacs session here connected to a Clojure REPL, and that REPL contains these dependencies here. So these are the two dependencies you need to add in order to run the debugger for Clojure. Okay, so let's start. For using the debugger, first you need to require FlowStorm API. I'm using the debugger alias here, and after that you can run the debugger whenever you need by running local connect. It's going to start the debugger. You can stop the debugger if you don't want to use it anymore by calling stop. And there are some options you can use to start the debugger. So you can start it with a dark theme, or you can start it with a dark theme and also some extra styles. I'm going to use this to start it with a bigger font, since I think it's going to work a little better for the demo. And yeah, this is how you run the debugger. Now let's trace some code. So let's say you're working in some piece of code here at the REPL, and you want to see how it's working. And so you want to step over this piece of code. You can use rtrace for that. Rtrace means run trace it. So it's basically instrument this piece of code and also run it. So let's run this code. And first thing you see here, it's a null pointer exception. So there is a bug with that piece of code. How do we use FlowStorm to debug what's happening there? Let's get rid of that. So yeah, here you can step over the code using these controls here. One thing we are going to do for the exception, it's go to the last thing we were able to execute. So as you can see here, we are on the drop 10 form, and yeah, so this is the last thing the debugger was able to trace before the exception. So the exception is right after executing this drop 10 here, and yeah, as you can see on the value window. So before that, I mean, you can step, use the debugger to step on the code, and this window here is going to show, this panel here is going to show the current expression value. So we are here at the drop 10, and as you can see, there is a nil here, and this is probably what's causing the bug, because the next instruction we're going to run, it's reduce with plus, and that's going to fail for the nil. So this is how you use the debugger to try to figure out what went wrong. You can step by using the controls, or you can click around and travel through time to the part you want to take a look. Okay, so now we can, okay, this nil here, we can, let's say we can want to fix this. So let's remove all the nils, run it again. Now everything went fine, and we can also step and take a look of what happened in case we are interested. So yeah, you can, whenever you want to get rid of the state of the debugger, you can hit Ctrl L, same keystroke you use for your terminal to clear everything. So let's move on. So you can instrument any function from the browser or using the trace tag. So FlowStorm contains a browser here. You can use it to inspect all your loaded namespaces and your bars. Let's type here demo to shrink this list. This is the namespace we are working with, and here we see the factorial function we have here. let's say we want to instrument it function. Let's running and see everything is fine. So let's instrument this function. You can click there and you can click instrument. As you can see, it's going to show here, this bar is instrumented. So now when you run it, debugger should pop up, and yeah, you should see here, and you should be able to step over the code, or also use the other tools. So here we are seeing the code tool, which we can use to step over the code, and next to it we have a tree with each kind of an overview of the call stack. So you can see the factorial of 5, call factorial of 4, and like this. And you can click here and see the arguments, and also jump around in time. Let's say you want to go where 1 factorial of 2 was called, you can go to here and it will jump exactly there, and you can move from there. Okay. Yeah, that's it for instrumenting from the browser. But also see, if you reevaluate this function, the browser it's aware of that, and it's going to remove it from the browser. So yeah, you can also instrument function by writing trace on top of it and reevaluating the function. Also see that the debugger is aware of that, and so yeah, you can instrument from here or from here. What is the advantage of instrumenting with by writing trace on top of your code? It's like if you are constantly modifying this function and reevaluating here, you are going to have to come here and hit instrument again and search for the bar and hit instrument again. With writing this here, you just every time you modify the functions and you reevaluate this, and it's going to be instrumented every time. So then you just call that and come here for stepping over it. Let's get rid of this, call it again, there it is. Okay. If you uninstrument it, by just deleting this and reevaluating it, then the debugger will not pop up. Okay. So this is important. Be sure your file is saved before instrumenting from the browser functions you just wrote. This is because let's say we just wrote this thing here, and so yeah, we evaluate this, we call it work, but before instrumenting it from the browser, we're going to see some here, you need to be sure that the file is saved, because the debugger should be able needs to be able to find the source code. So here we should be able to instrument this, when it runs, it's there. Okay. So yeah, let's move now to how to instrument library code. So we have seen that you can write trace on top of, or just use the browser. For instrumenting library code, you can use the browser, same thing. So we can type here, let's say we want to instrument this Clojure set different functions. So we can search for Clojure set different function, instrument it. Okay, here you can see it. So now when you call it, we should be able to step over the different source code. Okay, come here and instrument both. Clean debug. You can also instrument entire code bases. So here we are going to run the Clojure script compiler. So we have the Clojure script compiler loaded on the class path, even if it's not showing here. FlowStorm, it includes a version of Clojure script inside, its dependency contain one, so we should be able to call the compiler I added this utility to just call the compiler, and we are compiling one file here. Let's see if it works. And yeah, it works. It's printing factorial 5 of 120. This is just the script we are compiling. But let's say we want to instrument the entire Clojure script compiler. We can come here to the browser, look for CLJS, and yeah, let's instrument a bunch of the CLJS. Oops, sorry. A lot of the CLJS compiler stuff. All this should be enough. We are going to use light instrumentation here, which means instrument everything, but only like function calls and function returns, and not everything in between, not every sub expression, because we just want to go into an overview of the compiler and not to like single step into everything. It's going to be a lot, but you can instrument the compiler, fully instrument the compiler. So here, as you can see, we have instrumented all these namespaces, and now let's get rid of the debugger state and let's compile something. Not everything is instrumented. Okay. Let's see here on the repl, and we have everything compiled and executed, so everything is fine. And now we can use the debugger to walk over whatever the compiler did. So I like to start with this overview window. We have a couple of overview windows. This is going to show the call stack tree, and this other window here, it's going to show every function that executed, sorted by how many times it executed. You can search here for emit or whatever you're trying to look at, and but let's use this one. So yeah, you can click around here, and it's going to show the function call with the function return, and you can use whatever you see a value. It can be here, or when you're stepping over code and you're interested in inspecting, because it looks kind of complicated to look at here. You can click the inspector button. This is going to open an inspector where you can click and start digging around, which is pretty convenient. If you found some value you are interested to keep working at the repl, you can click the define button. You give it a name like P or whatever, and then you go to your repl, and yeah, you're going to have the value there to keep working from the repl. Okay, so that is the inspector and how you define values. You can use this other window here. For example, if you are interested in parsing and how it Clojure script compiler parses namespaces, you can double click here to see all the function calls. You can get rid of some arguments if you're not interested in all of them, and then rerun the function. And here you can see it's this analyze parse. It's being called with all these namespaces forms. And if you're interested in any of these, for example, let's move the debugger to the place where it's parsing our the namespace we are compiling. You can hit go, and go there to this def method body. As you can see here, because we instrumented everything light, we are not going to see. We are not going to be able to step over this code. Everything is grayed out. But if we are interested in this, we can right click here and say, okay, fully instrument this form, and it's going to instrument everything. So yeah, whenever we run the compiler again, let's run this, and then go to that function again, and it should contain all the traces. So now we are able to step over everything, inspect every value, and everything should just work. Okay, so that is how you instrument entire code bases, how you go from light instrumentation into full instrumentation. And yeah, let's get rid of that. And let's also remove all instrumentation. Okay. Let's move on now to debugging loops. So let's say we want to inspect the source code, a step over the source code of the string join function. So we go to here, we look for string join, we instrument that, and yeah, it's already running there because it's probably in repl tooling it's calling the join function. So let's get rid of that call. I want to call it and see our trace. Okay, so when you start stepping over showing source code, you're going to see that there is a loop here. So all this form in each iteration took a different value. So when you click, for example, more, you are going to see all the values that more took during every iteration, and you can use this menu to move the debugger to that point in time. I haven't talked about this before, but this is this counter here. This is the amount of traces we got when we ran this function, and this is where we currently are. So we are on step 35 of 86 steps. So yeah, you can, whenever you are inside a loop, you're going to get one of these menus. And if you're interested in going just to the last iteration, this is useful because if you have like, I don't know, 5,000 iterations or whatever, scrolling through this menu is kind of annoying. And sometimes you are probably interested in the first one or the last one, probably not everything in between if you have that many. So yeah. As you can see in other threads are the tooling, probably in repl, it's calling join. So let's uninstrument it and clean everything. So let's move on to tapping. So FlowStorm contains this tool here called taps. You can use to send whenever you tap something, it's going to end up there. And it's also contain a tap tag, so you can use to tap something and also return. It's pretty handy. Let's say we are defining this this map here, and we are interested in tapping this value here. So when you call that, it's going to tap this. You can double click on any tab and it will open the inspector, and you can use that to inspect value, even if they are like infinite sequence. So in this case, this is an infinite sequence of all the odd numbers. Yes, so you scroll, it's going to show 100, but you can keep clicking more, and you should load more and more forever. Okay, so that is how you use tabs. Whenever you hit Ctrl L, you should get rid of everything. Yeah, now I'm going to show you a new functionality that's available on FlowStorm version 3, which is you can access the entire. So when your instrumented code runs, it's going to generate, as an example, I'm going to create traces, very small debugger. Then the debugger UI is querying those indexes, but you can use those indexes also from the repl. So this gives you a programmable approach to debugging. Excuse me. So how you do this? For accessing the indexes, you have this index API, so you need to require that. So as an example, I'm going to create a very small debugger that will replace, it's going to be a repl debugger that will replace what this UI, what this UI is doing. So let's do that. So I'm going to require a couple of extra functions. This is just for pretty printing and adding some colors, nothing special there. We are going to define an atom so we can keep track of what step we are. Let's first instrument something and trace something so we can use it. Let's do our set difference. We instrument that. Let's run this again. Okay. Now we have something traced, something indexed, but we are not going to use. Let's get rid of the UI. I mean, we have everything indexed. We don't need that UI. So yeah, this is the flow ID and thread ID we are interested in, and let's define this function and start using the index API. So we can use the index API to return any index of the timeline. You just give it flow ID, thread ID, and the index. In this case, is going to be the current index we are in. So we grab the coordinate and the result, and then we have the form, and then we just print the form with that coordinate highlighted, and also we print in yellow the result. That's all our show current function does. And yeah, now we define step next, which is increment the index on 1 and then show where we are, and the same for step previous. So let's evaluate these functions, and now let's go to the repl here and should be able to step next. And as you can see, it is, we keep stepping next, and it's showing us the form with the current form highlighted and the value that form evaluated to in yellow. So yeah, we can use this as a debugger also, and yeah, by accessing the index API, we can create tools like this. We can create tools that search into the execution traces for some patterns or whatever. And yeah, this is all I have to show you today. I hope people find this useful, and yeah, that's all. Bye bye.